And in general, you don't want to wear gloves when you're like on a like a Bridgeport.
Right. Caught.
And then, yeah, same problem in the wood shop. I got the box mounted.
What's that?
You got the box mounted under your...
Yep, we got that. Still working on the wooden handlebars, but still in city.
Sweet.
I was wiring up the electronics hopefully later today.
My business partner's been rebuilding a Bosch electric bicycle for a while.
Whoa.
Yeah.
Didn't know Bosch made the electric.
I didn't either. They make the motors.
Okay.
But yeah, he got it for almost free. He lives in the Netherlands. They have.
Yeah, so.
Alright, so I'm actually gonna pull the tool piece straight. So we have that as Alright, so let me know when you wanna sort of keep oils off that collet. You wanna make sure it's clean. Yeah, and I guess watch out to not do what I did when I turned it on. So I'm just gonna get some little weight down. So after machining, this is almost always clean, but you can see there's a little bit of aluminum chips in there. That'll happen. You can just blow it out. And then the same actually goes for these collets. So that's the collet nut. I find the best way to clean it is just like that. Get a decent amount out of it. And that will affect the ability for the tool to pull out.
Right.
So there's a whole lot of junk in there. It's not great. What we could try to get eventually is they actually sell little tiny covers, like rubber covers you can stick in there. I don't know if they fit in all collet nuts. You might need a nut that accepts the covers. Same thing for this. Like, these are actually getting kind of dirty. And it's sharper than... okay. If you want to start filming.
Yep.
Okay. The first thing to just know is these are ER20 tool holders, and when you want to put the collet into the collet nut, you want to make sure you do it slight angle and then just push it in.
Cool.
And then you mount the collet nut onto the tool holder and close it. If you instead take the collet nut, drop it on there, or put it in here, and then try to do that, you will break it.
Okay.
So that is these things are about like $25 a pop, so good. It's not a good mistake.
And are they all ER20?
No, we have 3 different types of tool holder. We have drill bit holders, so these are traditional, just little chuck.
Gotcha. So ER20 is the collet size, or the taper? Or the...
So ER is actually just it's like, it's the brand name that originally made these, like Ergo Rex or something. That just has to do with the way these are sort of eccentric nuts that lock in the collet. The nice thing is there's a taper on the inside of this, so the tool ends up getting clamped from each of these individual little clamps. It's probably the best system you can have.
Gotcha.
Outside of like shrink fit or the really expensive. The other system we have are these sort of like old school tool holders.
All right.
I forget what they're called, but I hate these. I never use them.
Yep.
The problem with these is because there's just a hole that's slightly oversized that you're putting the tool into, and then there's a little indent on the side of the tool that you're locking it in with this nut. That will always, or the set screw, this is always going to be slightly out of, it's going to be not quite concentric.
Right.
That means your hole's never going to be exactly the size you want. It also means that your cut quality is going to be a little worse.
Okay.
So, get the tool in there, you just loosen this up. Side tool, and you can see this has the, if you're going to use the other holder. Get that tool in as far as it'll go while still leaving a little space for the flutes. So, there.
Cool.
And then lock it on there. And at this point, I'm just going to go on to turning the machine on and come back to it. Okay, so to turn the machine on, first thing you want to do is just go in, make sure there are chips anywhere in this amount. Issues,
it makes it easier, to have something that people need sometimes. So right now when I'm talking about what I do in lieu of those sheets that I showed you is
leave the device handling.
Okay.
So you want to take that out, probably. So first thing I'm going to do here is just check, make sure right now you can see that the drawbar is in contact with the power drawbar.
All right.
So we want to just remove that contact. I'm going to take a it's in there.
So you push,
Now you can
push
see
it in, and then release the button.
Push the button first, then we'll let you put the tool in. Put the tool in, then release the button. So that's no longer making contact. Check. We can close that. We just want to make sure there's a tool in there if we're going to run the machine. Then we come over here. This is watching. Then we come over here. Turn on the controller. Just to wait for this to boot up. It's going to be a little while. While that's booting up, you could come over here and just make sure the device is. Hopefully this will be clean from the last person who used it. The main thing you want to look out for is make sure there aren't chips on the device.
Yeah.
This is very and in general, it's good to just make sure. This part actually is always wobbly.
Okay, right.
Tormach device thing. Won't happen on like a curve. Okay, so the machine's now on. First step is to turn this knob. That's the controller power. The second step is to come over here, release the e-stop.
So turning it counterclockwise, clockwise. Okay.
You don't have to go. I just went the wrong way first.
Oh, okay. So clockwise?
Yeah, just
direction of the arrows.
And pop it out.
Gotcha.
And then that will power on. You get the green light. And then after you've done those two things, you can hit reset. And you just want to make sure that you power this controller on first. Otherwise, the machine could run out of control.
Right.
So now that we're in here, we're going to reference the axes. We'll just do those one at a time. Once they're referenced, that light will turn green. Okay, so we had an error, which probably actually haven't seen that one before.
Good.
But it's probably that. So the X and Y homing switches both have electrical issues right now. So it looks like it feels that it was touched before we tried to make a move. We'll just try that again. We have to clear the error first.
So it's a kind of template that you use already used in Shapeoko, right? Wherever. Yeah. And this is nice. We already have a questionnaire, discussion, things like that.
This is what I was worried about. First thing.
Well, glad it's sure it'll happen again.
In February, we can start teaching.
We can try referencing the next.
Teaching physical.
Okay, so
And then they like to.
it doesn't appear to be letting us. Try rehoming next. It's not doing it. So, okay. Alright. So we're gonna have to restart the machine.
Cool.
Actually, we don't need to restart the controller though.
Okay.
We can just stop that. Do that. For like 5 seconds. Alright. Clear all of those errors. Reset that. Okay. And so this actually threw up another error. The X switch triggered a reset. We didn't get an error here. But we know that it triggered a reset because this went back to the reset condition. So we can reset that. But we will need to re-home X even though it thinks it's home. Okay, and that time it didn't trigger
Cool.
the reset.
So you just manually moved it away from the X limit.
Yes. So we will be replacing those limit switches, and hopefully this will stop. So same thing happened again. We triggered a reset with the Y. Now we need to reset everything. Even though it took the Y and the X, you'd have a nasty surprise if you did all the rest of the steps and then tried to load your program. Yeah. Okay, so it's now sort of stuck on that Y switch. We're going to reset the machine again. So if you get it stuck in this cycle, this could take a while. We could probably stop recording. This might take like 5 or 6 more resets.
But this is all you're going to do is the same thing over? There's nothing else to...
Basically, once you get past referencing all these things, if you get in this situation, what you want to do is just try to get the table away from all of those homing switches.
Gotcha.
Once you do that, it's going to behave perfectly fine for the rest of the time. And in an absolute worst case scenario, say you're here, you have to do a project, you really don't care about... So what homing will allow you to do is if you lose power to the machine or something catastrophic, you hit the E-stop. If you hit the E-stop, then you will rehome and be able to go back to your part.
Gotcha.
In theory.
Yeah.
However, if you're just really desperate, you can disable the reference switches.
Okay.
And then that would then allow you to machine without
Right.
Otherwise, it will not let you do anything without homing. So it's sort of like, that's not necessarily something you would assume, I don't think.
Right. Good to know.
Yeah. So, okay. So we've got it home, which is a little journey. So the next step usually for me is just to load the part in.
Right.
So I'll move the vise slightly off of the center. And actually, usually it's good to put something that doesn't have an end mill in here, because if you bump your hand against that, it's like a knife that will cut you. So to load a part into the vise, we're going to use these. So these are just parallels, and we don't need particularly tall ones for this part. Just like that. So I've already machined one side of this via reference side, so that's that side. I could use slightly taller ones actually. So
just to give you a little more clearance between the tool and the vise.
Yeah, the part and the vise. Yeah, exactly. Oh yeah. Yeah, because either if the part's not completely cleared, so here I have reference surfaces machined on either side of the part, so it can sit above the vise. But if for some reason there was it wasn't perfectly flat on the bottom, that would be an issue. So you want to prep your part. This part's already prepped. Just always put these guys back. What you want to do is Get your part roughly where you want it. Press down, close the vise, take the dead blow, slams, make sure it's in there, then you can pull this. Now, on the Bridgeport, or well, on any machine where you have like a Kurt vise or a precision vise, at this point you'd be able to tell if you did your job right by seeing if you can move the parallels.
Right.
This parallel won't move, but I guarantee that this one will. That's a this vice problem.
Right.
But it shouldn't be. So
But you're still confident because you hit it that it is in fact flat?
Yeah, I haven't had parts pull out, so yeah, it's as flat as it's going to get in this vice. I believe the reason actually is because this vice is not putting enough downward force on the rear jaw. Next step is we are just going to use the edge finder to touch off our part. I need to. So it's been a little while since I'll load the file notes actually too. So we're gonna load our file. I don't remember. I'm pretty sure I put the. Pretty sure that's the part center, and that's what. So basically, what I'm gonna do is that's gonna be my X0, Y0,
Okay.
and my Z0. So
Is that what you typically do in the top center?
Typically, I'll actually use this corner.
Okay.
I really like using that corner. I think it's the northwest corner.
Mm-hmm.
Is usually how it's defined in CAM software.
Mm-hmm.
Just because if you define that corner and then you put in a stop,
Yeah.
You can pull apart and just repeat
Right.
over and over. And then if you, for some reason, lose just your X,
Mm-hmm.
if you lose your X and Y, your Y is set to the rear of
Yep.
the vice job, so you don't need to do that again. And then you just have to redo your X, and it's always pretty easy. Whereas if you do this, I'm going to have to touch up here, average it in the middle, here, average in the middle. What this is good for is, I just wanted to try to guesstimate the center of this rectangle, because it doesn't matter to me if the bottom part of this is aligned at all.
Yeah.
It just matters to me that I'm sort of cutting within this space, if that makes any sense.
Yeah. Yep.
So what you would do is you insert your USB device, your USB drive. I just have a folder with the, that's the CAM program for the part. I actually already have it on the drive, so I don't need to move over, but it would just be copied from USB.
Hi, how are you?
Then you just double click over on them, and then real quick, just select your part over here. I like to sort it by date modified, so it'll show you what the most recent parts moved over are. Just double click on the part, and you're in your part file. It gives you a little preview of what it's going to be doing. Now right now, this preview is throwing up an error. So the reason it's throwing up an error is we're exceeding the x-axis at the moment. So we're going to just go in and touch off the part with the edge finder, and then that error should go away. So this is the edge finder. It doesn't actually have to be in here like super well, but we'll just check. Usually nobody takes this out.
Right.
So I'm just going to come over here. Draw bar. Now, if you were to hit that button with not holding the tool, it would just fall. So always hold that tool.
Definitely hold it.
And that's how you change tools. So the edge finder, the first thing you want to think of when you're doing the edge finder is just go in here, check the RPMs. Right now it's at 10,000. If I ran the edge finder at 10,000 RPM, it would destroy itself. So I'm going to set this as low as it'll go. Usually under 1,000 is good.
Okay.
So I believe 680 is as low as the machine gets. Just offset this. So this is a little tiny disc that's attached with like a springy cable. And I just want to make sure it's offset. And then once it's offset, if we run it, you can see it's sort of wobbling. They're also called wobblers, I think so. So this is going to come in. You want to make sure you're not too far down.
Right.
So that sort of black area up on the top between the where the disc is, that is too low. So you want to make sure if we were to stop this, you can see that there's this polished area. You want to make sure that that's coming into contact with your part. We're just going to move over. The nice thing about this one is I believe it makes noise. That's a wiggler is what some people call it. So usually you can just see visually as you start to touch it. It's not going to... And as we come in, I'm using the inner knob that has the indent for your finger to do the smallest movements I can do. So that's thousandth of an inch or 10,000.
So you're selecting the axis with a button, and then and then outer is larger increment, inner is smaller increment.
Yes, exactly. And the smallest is just going to be slowly moving. The outer will ramp based on how far you turn it, so it can increase in speed sort of like suddenly. So it's in general good once you're anywhere near the part to use this inner wheel. Does it want to do that as far as I know? It's not a nose maker. So now I'm just setting X to 0.
Okay.
I did that just by hitting the X button.
Right.
Then I'm going to go to Z. I'm just going to move this guy up. And this is the part you want to be careful about when you're starting. Because if you go the wrong way with Z, you can crash the edge finder.
So, and okay, so you just learned that clockwise is positive. Is that?
Yeah, this is something you should get familiar with before you are really ginger with it. So right now we're at X0.
So we're not accounting for the thickness of the edge finder.
Usually we would, but for I'm pretty sure I usually don't touch off parts like this, so yes, usually you would. I haven't been using an edge finder lately. I've been using a thing that makes it so I don't have to account for the thickness of it.
Right.
I don't think you do, though, for if you're doing 2 points, 1 point on each side, because one side would be negative, one side would be positive, and they cancel each other out.
Oh, right, he was doing the middle.
Yes.
I forgot.
Yeah, but no, normally, that's a good point. That it's a 1/10 of an inch, I think, is the radius.
Okay.
Yeah, so yes, normally if you're doing the, okay, so we're just moving to the other side of the part. But now, let's not go too far. And come back over. A little more. So this is the part where if I turn it too far, it could break the edge finder. But so if you're new to using it, you probably want to start using the inner dial by now. But it will take you a lot longer. So, all right. So we touched off. I'm not going to be too accurate right now because it doesn't matter that much, but. So right now our X's reading is 3.1850. So I'm going to take that, get the middle of it.
Divide by 2.
And then I just go click on that. And actually, if you want to be extra safe, you could move over to Z and just raise that up.
Gotcha.
In case you accidentally did something. But, and then you're going to type in half of that value.
Cool.
So the nice thing about that too is I've averaged the error of those two measurements. It's not super necessary here, but if we do things right, we should get a hole right where that other hole is already. So at this point, I could just jog over to what I think is X0 and see if it looks like I'm in the middle of the machine or middle of the part. So, I mean, yeah, it looks okay.
That's pretty middle.
If we do that, it's not too bad. It's like right on line with that. So I'm just going to do Y. And this takes a lot longer than the Z gap. One thing you can do is if you want that to wobble more so you can see it, you can just knock it out of alignment.
Okay.
I don't know if we really want to teach that to people. generally, as long as you keep your hands away from the spindle when it's running.
Better.
Yeah.
Better outcomes.
Yes. Okay, so we touch it off. And yeah, I guess the nice thing here is you don't need to know which side to compensate for.
Right.
Because that can be confusing sometimes. Now, hopefully we can get to the edge of this part. That's going to be...
Yep.
Yeah. Okay. I mean, you can see how rough that edge is anyway. It's not really accurate. There you go. Okay, so let's look at 2251. I'm just going to change that to negative. And you got to make sure you get that sign right. But all right. Go to Z. Lift it up. Spindle up. Now this is something that's useful. We can bring the spindle up as far as we'd like to do a tool change. We go over to offsets and hit set G30.
Okay.
For now on, wherever as long as we're in some place and we want the spindle up, so say we were where we just were, you just go to G30, it'll do that for you.
Nice. Does G30 have a meaning, or is that just...
G30 is the reference point for tool change.
Okay.
So if we had like an auto tool changer, we would set that height to where we want it to be for when the carousel comes in. Use that. Okay, so now I'm going to really quickly cheat and figure out what my tools are. I have 3 tools. So the nice thing about Fusion is it gives you this little sort of macro at the top that gives you information about your tools. So I know that I'm going to need T2, T12, and T26.
Nice.
And those are stored over in the offsets area. So T12,
nice.
I put my name next to ones where I know I'm going to use them all the time, and if someone erases it, that's fine. But so T12 I almost always use as an 1/8 inch.
Okay.
So to measure the offset for that, we're just going to put this in here. We have this extremely sophisticated USB device. Plug in over here. So what we're just going to do is, the first thing we need to do is do tool offset. So you lower the tool setter, set it to 0 on here, and then it's kind of hard to see, but you hit 0 on here as well. And then you just raise this up, drop it onto the tool. It's reading in millimeters right now, so we want it in inches. And then we just hit data on here. So data. And so this now reads 2.9772. This reads 2.977. Sounds good. If those are wildly different, do it again. And then the second tool I had on here was tool 26. Okay, so the diameter is 1/2 inch.
Cool.
So I'm just going to grab the existing 1/2 inch. Make sure it's in there. And that is tool 26. If we scroll over on our offsets to tool 26, I have labeled it, set the diameter already. So if you're creating a tool, you do need to set the diameter. It defaults to 0.
Gotcha.
I don't think it really matters too much on here. It might throw up an error if it's not the same. On like a fancy controller, it would actually do offsets. So as you use a tool, it wears down a little bit. It'll actually compensate for that with cutter compensation, but I don't think Tormach has cutter compensation. So then just go back over here, hit 0. So depending on where this is, the heights change a little bit. It's not the greatest tool setter in the world. And then you also have to 0 again on here.
Right. Okay.
If you don't 0, if you 0 on here, forget to 0 on here, you'll feed the wrong data in. Let's go up. Hit data. So it's saying 3.5811. We have 3.5805 on here, so close enough. Okay, so we have one last tool, which is going to be a let's drill. And hopefully it's the one still loaded in here. This is a number 17. Which is 0.173. That is 0.1719.
Okay.
So that's probably what I wanted. Put this in here, you just drop it in. It's basically just like a drill press. And that was listed as tool number 2. Okay, so number 17 drill. I guess I could have just checked there. Do the same process. 0 that. 0 that. .775, 4.7748. So we're good. Alright. Then I just like to arrange my tools so they're in the front right now. Right there. So we're going to be using these 3 tools.
Cool.
The first tool in the program is usually the one you want to load in to do your Z touch off. And you're going to find that right here. This T12 is the so in G codes, if you see a T, it means tool.
Okay.
It's not going to be there for any other reason. Tool 12 is our 1/8 inch.
Right.
Yeah. And then load it up. And then I like to use. We have a sheet here. This is a 1/1000 of an inch thick. Find a flat spot so that's in depth. I don't want to use that. Definitely don't want to crash this. Go. Now Z, that's gonna hit that. We want to set it to the 1,000 inch offset. Yeah. And then this is the time I really like to just go to G30.
Get it away from you.
Yeah. You don't want to crash it at that point. So. Alright, so we're all set up. In theory, we should be able to run this. We don't have any cutting fluids, so we can cheat. Just get a little WD-40 on there. It's not really ideal, so we're going to probably be running a lot slower than we normally would, and this is not a good thing. Make sure it's full at the beginning,
okay,
and then it automatically comes on its own.
Oh,
so as long as it's turned on in your program, you could turn it on manually here. If we click it, nothing will happen right now.
Right.
So, but you would actually just see that come on automatically. There's a code in the G code that will turn cutting fluid on and off. With the air, we're going to set that up so it comes on automatically as well. And then there's going to just be a switch where you select whether you want air or cutting fluid.
Cool.
So if we didn't need the auto tool, the power drawbar plugged into the air, I would use air. It's okay. So the smart thing to do when you're first running a program is set this at something really low and be ready to hit stop or the E stop.
All right.
If you hit the E-stop, you're going to have to redo the references, so generally I like to be just hovering over the stop.
And you set it at 7% just to sort of see it start?
Yes, yeah. It's going to actually, yeah.
And when you did it in Fusion 360, you told it there was coolant, or there wasn't coolant?
In Fusion 360, I probably left it thinking there was coolant.
Okay, so you want to go slower than full speed?
Yeah. Well, I manually set the speeds to ones that I knew will work for air.
Oh, okay.
Which is called dry machining. And in general, like, dry machining is not a terrible way to approach things. This is a terrible way to approach things with no coolant whatsoever and no way to extract the chips. The main job of coolant is actually to get chips out of there.
Gotcha.
It's not necessarily to cool the part. That is a secondary thing, and lubricating is a secondary thing. My understanding is evacuating chips and lubricating is actually the most important. So we might have to go very slowly here. We'll see how well it goes. We might break in. So the danger is that you're going to heat up the aluminum's going to become soft.
Yeah.
And then at that point, the aluminum will cling to the tool, and you won't be cutting anymore. You're just going to be dragging a tool around in sort of an aluminum suit. So we can go a little faster. The downside to going too slow is you can start rubbing, and then you're creating heat.
Yep.
So particularly with aluminum, you don't want to rub. What we've done, so this is actually a very aggressive tool path, which is not optimal for using any coolant or any chip evacuation. So what this is actually a high-speed machining path. So yeah, we're doing a. Did it break already? Yeah. So that's not too surprising. It really needs to not do everything I had to do right there.
Right.
But we can evaluate what happened there. So it got in there perfectly fine. I bet you that if we go to G30, another really great use of that. So if this happens, this is an ML I brought in. It cost me like $3. You just load another one in, clean it up, figure out why it happened. But if you don't have to reset anything,
not a huge problem.
Not a big deal.
Do you need to remeasure the bit and put it back in?
You will need to remeasure the bit.
And so for end mills, is our policy you buy and bring your own, and then what we have you can use?
I think that there is we should talk to JR about exactly what we want the policy to be. We have new end mills that you can buy.
Okay.
And then we have old end mills that you can use with some like caveats. So like if you're breaking them, probably replace them. And some of these are actually pretty expensive. So like these guys aren't. So you could use these guys. They're double-ended end mills. It's almost identical to what I was using.
Yeah. And where do you buy them from?
I'm trying out Online Carbide.
Okay.
So that's an eBay shop, and then they have their own web store. They have good prices. I'm not in love with their end mills yet, but for the price, like especially if you're learning, this is how you're going to break end mills. It's not going to be wear. Like this end mill should last like about 2 hours.
Okay.
So it did not last 2 hours. So we can just sort of go in there and see what broke it.
Do you think with coolant it would have?
I don't know actually. Yeah, probably. We can put another one in there and just see. I mean, so the downside to some of these end mills is they are like probably not great. I got them so cheaply. I know there's something wrong with them.
Right.
So it's also possible this end mill just had like a weakness, a weak spot. In general, you want to get rid of the sharp bit, but the bottom part of these end mills are actually useful as dowel pins if you grind them down.
Okay.
I mean, it's like take a $3 end mill, turn it into a $2 dowel pin.
All right. Hey. Start going to business.
Yeah. All right. So if we look at where that went wrong, I'm just gonna make sure this is. I'll try this with another angle just to see what happens. But temporarily, I'm just gonna disconnect the air. I want to make sure we plug that back in.
Right. And that air goes to the power drawbar.
Yes. Yeah. So eventually we should have, this should be connected to a different airline and always available. So we want to be able to do that. So if we look at the part, it actually doesn't look gummy to me. It's a little dull. So one of the things you'll see is it'll go from shiny a good cut is going to be really shiny.
Right.
If it's starting to get dull, you're rubbing, you're not. So it might just be that we were going too slowly. The part's not hot. Like if the part was hot, this would be painful.
Gotcha.
Yeah, it's just very possible that either the program's too aggressive, or there's something wrong with the end mill, or we're just rubbing too much, and it wasn't cutting, it was more rubbing, and we actually wanted to go faster. What I'm going to do for our reset is just...
And this is Teflon, I think, right? Or graphite?
Oh,
yeah, it's Teflon.
No, I don't want to be using this at all. Shit. There's been a can of not this here for a while.
Do you want? We have W40.
Yeah, we just want regular W40.
Okay, here's this little guy.
Yeah, but we can. Yeah. That could be part of the problem too. Yeah, there we go. That's much better. Okay. I didn't even know W40 made Teflon. Okay, that could be the problem too.
All right, good to know.
All right. Okay.
And so that's what you wanted to use when you're cleaning the parts as well? Just normal WD-40 versus
normal
Teflon?
WD-40, yeah. The Teflon's not going to
hurt anything.
I don't think it would hurt anything. I mean, it's a thin layer. I didn't really spray it on there. I sprayed it on there. So. If anything, it's just going to lube up.
Slides right out.
Yeah, exactly. I think more generally, we don't want to breathe in Teflon. So
right.
That's probably the main reason we didn't want to do that. But, always check the bottle thing. Make sure it is what you think it is. Okay, so we're just going to remove this. And they can be sharp, so just be careful. But yeah, I mean, that's a perfectly good dowel pin. So, but I generally like. And that was a used end mill too, so I don't know how used it was. But I actually wouldn't be surprised if the Teflon wasn't the culprit. I don't know. It's. I don't get too upset when these guys break just because they're so cheap. But yeah, ideally we want some. What we can actually do is. No, we can't take air off of the spindle. Yeah. I was gonna say maybe we can unplug the spindle and use air, but we can't do that. So. I'm not in love with that design choice. Alright. I don't know. Sorry. I need to measure this first. Okay, so we're just gonna go back into offsets. We're on 12 already. Pretty close. And yeah, we shouldn't need to remeasure the touch-off because it's because we updated the offsets, it should be fine.
Right.
So I'm gonna just spray that down with a little more of the this guy's the regular. Usually this is good for tapping more than milling.
Right.
The one thing you never want to do with WD-40 that's probably okay to do with that Teflon stuff is lubricate lead screws.
Okay.
Because it will sort of gunk up. The same reason you probably don't use it for bike chains. Alright, so just gonna go back and do another.
Are there lead screws here that you lubricate?
No. I mean, eventually we should.
Okay.
But I've cleaned the ways and lubricated the ways, but I haven't done the. Oh, and actually, that's the first thing. The first thing we probably should really do. It's getting increasingly difficult. Is there's a pump back here for just making sure the ways are lubricated.
Oh, okay.
I usually do when it first comes in. I don't think it did today. I don't know if you can see it.
Oh yeah, there's just that handle right down there, and you pull and push it a few times.
Yep.
Okay.
Yeah. And just make sure the ways are well. Alright, so let's see if this is happy or not. I'm gonna run it a little faster this time.
Up to 64 from 7?
Yep. Well, that was at 50 when it broke.
Oh.
Yeah.
That's good increase.
Yeah, it's too bad we can't think it would be absolutely fine. We could move it much slower. I don't know. I don't know what's worse for it. A lot of times running it slower than you want it to is actually worse than running it faster.
And when you're slowing it down, it's slowing down the positional movement, not the spindle speed.
Yeah, you can do both. So you can...
Oh, gotcha. So that's...
Yeah. So we could... You have controllers for those as well as max velocity, which will include your rapids.
Gotcha.
Yeah, let's just see if it behaves with this. I also don't know if it's ramping. Now we're in the... It's going to make contact in a second.
Mm-hmm.
Oh, so it does speed up quite a bit.
And how do you know that it's going to speed up?
It would be in your CAM program.
Okay.
So when it switches, so this is one part of the operation,
Right.
That you have control over separately from the. So this is actually a trochoidal. It's a high-speed machining operation.
Mm-hmm.
So what's nice about this is we're taking a uniform cut. So if you listen to it,
Yeah.
it's getting the same load the whole
Yeah.
time, and that's really like what we want. Now I'm sure it's building up quite a little nest of.
Spray it down.
I guess we could do what I would generally not recommend doing, and just sort of try to get rid of some of that.
Okay. Oh, and
Yeah, I
Gotcha.
never do it this way. Always use cutting fluid, or dry machine is great. Like I don't break end mills with dry machining, and I get decent life out of them.
So wait, what's the difference between dry machining and not using coolant?
So right now we're not using coolant, and we're also not evacuating chips.
Okay.
Dry machining is not using coolant, but using a stream of compressed air.
Gotcha.
And then you can add to that with what's called MQL, which is minimum quantity lubrication. So that's where we take that stream of compressed air and we inject like aerosolized cutting fluid.
Gotcha.
You just have to be careful whatever you're injecting. You're okay breathing.
Right. So this is called just nothing. This isn't
nothing.
right.
This is making a pile of chips
Right.
that just get recycled into your cut. So our cut's going to be really bad.
Right.
Because if you kind of see it, like going in there and just, I mean, it's cutting chips as well as, and the danger is if it starts to melt any of those chips, they're going to just cling to the end mill. But honestly, this is, we're not going very fast. So the other thing is, we could probably safely do this at about 25 inches per minute to 30 inches per minute on this machine.
Oh, what's it at now?
Right now it's at 7.
Okay.
So again, the lifetime of the end mill is getting significantly reduced.
Yeah.
It probably does help that it turned down the RPM a little bit.
Right.
Because you want to try to hit that sweet spot.
And this is by feel, but there are also probably tables online for feeds and speeds. That you
Yes. Yeah, there used to be a really good online application called it was like GS Wizard or something, or FS Wizard, obviously. Yeah. And FS Wizard was available and then isn't available right now and might become available again. It was generally a pretty decent thing, but I find like everything's machine specific. So the problem most of the time is that this spindle is so odd that it's really easy to use a setting that makes total sense on like Haas or something, and on this machine will just not function at all as you expect. And the real thing you want to avoid is like breaking end mills, particularly when they're like 1/8 inch end mills that are not even carbide, is not a big deal. Like it's what, $3, $2 every time that happens. But if you crash the spindle, that could be $500. So like you don't want to. I mean,
So that's number one.
But yeah, number one is just try to avoid crashing the spindle. These little end mills will break before you're gonna, but like a 1/2 inch end mill on this spindle, you could crash it pretty easily. And plunging, you can crash the spindle much more easily than doing this kind of an operation where we're So it's that initial plunge that's the one you really have to worry about more. And in general, I think this machine handles this pretty badly. We'll have to see. I didn't necessarily check the speeds and speeds that carefully when I made it in Fusion, so we'll have to see. Particularly, I think drilling on this machine is sort of an art.
Okay.
We're using a small drill, so that's not too bad. But if you're using like a large drill, I don't know why they even. It's worse than a drill press as far as like horsepower. So it's got like less than half the horsepower of most drill presses. So you just have to imagine you're trying to drill a hole with like a hand drill or something, and then just treat it that way. So I'll show you when it gets there, but hopefully it's using G83 is the PEC drill cycle. So that drill cycle will just come in, come out, come in, come out, very cautiously. It's very hard to overload the spindle with that. But yeah, you never want this. This is quite ugly as far as machining goes. But that's fine, I trust it. I'm gonna pause it in between the next move so we can clean it. But,
and then clean up and shut down is just clean it off. Do you use air to clean it off?
Yeah, so normally what I would do is I'd vacuum it first.
Okay.
And then I would use the air to just blow off whatever else is there, and then wipe it down. And usually a little WD-40 protected isn't a bad thing. You don't have to do that every time. I think it's about like how long it sits in between use. This is a big improvement. So this guy will filter out some of the water in the airline.
Cool.
Because right now, that was what I was like. In general, coolant will. If we were using coolant, the machine would need to be dried off and just cleaned more carefully.
Yeah.
Because if you just leave it there, it's going to rust. So yeah, that's. Sorry. Yeah, that's usually like more important to do than if you're just doing dry machining. But it's also a good reason to like if you want to do less cleaning, dry machining is a good way to go too. Because it's less like. If you're using a lot of coolant, you just got to make sure you wipe that down, and then probably protect the surfaces with WD-40. Yep. Yeah. So when you're done, you would clean everything up, pull the tool. You don't necessarily have to pull the tool, but it's probably polite to do. It'd be good to put like just a blank tool holder in.
Okay.
And preferably, like if we had one of these guys without a tool mounted, that'd be perfect.
Right.
That way, if someone turns the spindle on, it's not a big deal. And it just also will keep the spindle a little cleaner.
Right.
So, like, especially when you're blowing stuff off, you want to make sure there's a tool in there. Because if there isn't, you're going to be blowing chips up into
good call. That's
surfaces.
important.
Yeah. And then you just want to make sure that you turn the machine off and then turn the controller off.
Awesome.
That's a big deal, yeah.
So I feel like there are obviously a lot of other components to machining, but I think we hit on most of the stuff that you need to know to use this machine.
Yeah, I think that once you understand how to properly select feeds and speeds and write your cam so that it's an intelligent, so you're not crashing into things or plunging too fast, that's the real like meat of being able to use a machine. This machine itself is not that different than the other machine, and it's not that hard to use, but if you can't write your cam software programs correctly, then nothing else, and if you don't set your feeds and speeds right, you're just gonna.
Though you can use it in manual mode, right?
You can. There's manual and there's also conversational. And that's probably, we should do a whole other video on conversational.
Okay, yeah.
But that's like if you want to do just a simple operation like face a surface, or make a pocket. And a lot of that can be done in conversational.
Cool.
Yeah,
we can do that some other time.
Yeah, that's great. So it's like, conversational is almost like if you wanted to automate tasks you would otherwise do in a manual mill. Okay. So that you don't have to stand there and do them.
Right.
And it's useful. I'll use the conversational for facing a decent amount.
And that's all on through this interface?
It's just all through the interface. And their conversational is actually pretty good. So,
cool.
Yeah. So.
Awesome. Thank you.
Okay, no problem.